Welcome back to Ms. Burkhart's math class. Remember to have your notes with you to fill in as you watch the video. And remember, you can always pause the video as you are watching it to be able to take notes and complete your notes. And also, make sure you go back, rewind, replay any parts that you need to rewatch to make sure you fully understand the concept. So today we're going to talk about Standard 6.12b, which is determining the unit rate of a proportional relationship and use it to find a missing value in a ratio table. So today's lesson, we're more specifically going to learn the definition of a rate and a unit rate, and also learn how to find the unit rate from a given practical situation. So let's get started. So let's just remember to go over a few things. Remember, a ratio is a comparison of two quantities. As an example, we have here 5 red Jolly Ranchers in a bag to 3 blue Jolly Ranchers. And if you recall that we can write that 3 different ways, we can write that as a fraction form. So 5 red Jolly Ranchers to 3 blue. We could also write it with the colon, 5, and then the colon, 3. And we can also write it with the word 2 as the way we really say it. And then today, we're going to add to our definitions, which is a rate. A rate is just a more specific kind of ratio. It is a ratio, but a rate compares two different units. For example, in this case, we have a bag of candy of 135 pieces of candy that cost $15. So what two different things are we comparing? Candy to money. Whereas if you look back in our first example, that was comparing Jolly Ranchers to Jolly Ranchers. So this is not a rate because it's comparing the same things. So again, a rate is just a ratio that compares two different things, candy to money. So our second word here for vocabulary word is a unit rate. So a unit rate is a rate that describes how many units of the first item correspond to 1 unit of the second item. As an example, a speed limit is a unit rate because you are comparing two different things, miles to hours, and it is saying in this case you are comparing 25 miles that would be traveled per hour, per 1 hour. So that's what makes it the unit rate, is the 1. So when are some situations we would use unit rate? We're only going to go over 3 examples today. So here's the first one. A kindergarten teacher is handing out cookies to each table of students so that each student receives the same number of cookies. One of the students at the table says, "Hey, that's not fair. They got more cookies at their table than we did." So is the student correct? Is this not fair? So let's look at the 2 tables. We have table A was given 6 cookies for the 3 students that were at that table, and table B was given more cookies, 8 cookies, for the 4 students. So is that unfair? What we can do is find the unit rate. Now, logically, you may be able to say, oh, sure, that's fair, but let's figure it out. So I want you to pause the video, and I want you to figure out, is it fair? How many cookies would each student get at table A, and how many cookies would each student get at table B? So pause the video and then come right back. Okay, so what did you decide? Was it fair? And what did you do to figure it out? Notice I've written the ratio here with a colon. I could have written it with the fraction, either way. So what did you do? Think about what you'd do in the classroom. You would say, all right, you would divide up the 6 cookies, right, among the 3 students. So you would divide them equally, of course. So how many groups did you divide these 3 cookies into? I'm sorry, how many groups did you divide the 6 cookies into? And yes, it would be 3. Why? Because there were 3 students. So what did we do? We said, okay, if I want to know how many cookies each student would get, what did you do? Well, we said, 3 divided into 3 groups, right? And therefore, just like we practiced before with equivalent ratios, remember we sometimes multiplied both numbers by the same thing, or we divided both numbers by the same thing to keep it equivalent. We're doing the same thing here. And we said, all right, well, we divided those 6 cookies into 3 groups. Why? Because there were 3 students. And so that gave us 2 cookies. So it says each student at table A would get 2 cookies. Well, now let's check table B. So at table B, there were 4 students and they got 8 cookies. So how many groups did you divide your 8 cookies into? You divide them into 4, right? Why 4? Well, because there were 4 students, so you had to divide it evenly. So in this case, we had 1, how much would each student get? Oops, pen's not working again. But so then what would you do? Divide by 4, right? Because that's how many students, and you wanted to know how much each student, how many cookies one student would get. And so I would do the same thing over here, divide by 4 to keep it equivalent. And what is 8 divided by 4? 2. So again, we have 2 cookies for each student at table B. So is it fair? Yes, because each student gets the same amount. So let's look at example 2. At Chuck E. Cheese, it costs $5 for 10 tokens. How much does it cost per token? So how much, and when it says per something, that means for one. So for each is another way of thinking of it. So here I have my 10 tokens, right? And my $1, $2, $3, $4, $5 for these 10 tokens. And again, I want to find the unit rate. How much does it cost for each token? So what am I going to do? Well, let's see my first ratio. What do I have? It is, I'm comparing $5 to 10 tokens, right? And again, make sure you're writing this down as well. If you need to pause and finish writing, please do so. So $5 for 10 tokens, I want to know how much each token costs. So I want you to pause the video now because I want you to think about how am I going to figure this out? All right, so what did you decide? Well, we can take each of our 10 tokens, right? I can, because I want to know how much each token is, so I'm going to divide these up, right, into equal groups. So here's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tokens. And now I need to divide my $5 up to match up with each of these tokens. But how am I going to do that? Because I only have $5. So how much would each token be? I'm not going to rip a dollar bill in half, but what are you really doing? You know you need to have half of a dollar so that each token, right? If you have 2 tokens, would be $1. How much would each token be? 50 cents, right? So you can have decimals in ratios. So here's what I mean. Let me show you over here. I wanted to know how much each token or one token costs. And what did you do? We divided it up into 10 groups, right? Because 10 divided by 10 is 1, which is what we wanted to get. And so what did I have to do to the $5? The exact same thing, because I had to keep it equal. And so I'm going to divide $5 by 10. Not 10 divided by 5. This answer is not 2. Because think about it. Would it make sense to say that each token was $2? If for $10 it would be 5? So make sure, and you can use a calculator for this just to confirm it. And you would put in 5 divided by 10, and it would end up giving you on the calculator this. But it's money, right? So what am I going to do? Put my 0 at the end. That's 50 cents for one token, for each token. Last example. Which is the better buy? 6 cookies for $3 or 12 cookies for $4? So better buy meaning which one would you get more for the same amount of money? So we're going to use our unit rate to figure this out. We're going to find out how many cookies I can get for each situation with $1 for $1. Now I could switch it and say, okay, well, how much would each cookie cost? That's another way to find the unit rate. But for these purposes, we're going to find out how many cookies could I get for $1 in this situation, and how many cookies could I get for $1 in this one. So let's break it down. Here is our example. the first situation, 6 cookies, $3. I want to know how much it's going to cost for how many cookies, excuse me, I will get for $1. So here's my first ratio, $3, okay? And here's my 3 groups. I want to know how much each, how many cookies I could get for each dollar, for $1. So I'm going to do what with my cookies? Divide them up equally, right? And into how many groups? Well, 3 groups. So if I had 6 divided into 3 groups, how many cookies would I get for my $1? 2. Each dollar, right? See how it divided up equally. So let's write that down. I wanted to know how many cookies I would get for my $1, showing my unit rate. So I divided it by 3, divided into 3 groups. So 3 divided by 3 is 1. I then had to do the exact same thing for the 6 cookies, right? And divided that into the 6 cookies into 3 groups. And that's where we got the 2 cookies for $1. So now let's take our next example here, which was 12 cookies, right? 12 cookies for $4. So let's just draw a line here. Let's write that first ratio down. 12 cookies for $4. And same thing, I want to know how much or how many cookies I would get for $1. So let's divide. Here's my $4. I divided those into 4 equal groups. Now let's divide our cookies up into 4 equal groups. So I'm taking 12 cookies, dividing it equally into 4 groups. Why 4 groups? Well, because there was $4, right? And again, make sure you are writing your examples on your paper as well. So now I have the same amount of money in each group and the same amount of cookies, so it is an equal ratio. And what do I have? For $1, I can get 3 cookies in this example. So let's show the math part for that. I wanted to know my $1, how many cookies I could get for $1. What did you do? We took that, divided it by 4 into 4 groups, so there would be $1 in each. Then I had to do the exact same thing for the cookies to keep them equivalent. And 12 divided by 4, 12 cookies divided into 4 groups, gave you 3 cookies. So which one was the better buy? Which one could I get more for my money? So that's why we compared it to $1. So in this one I got 2 cookies for $1, and this one I was able to get 3 cookies for $1. So this second situation is the better buy. I got more for my money. So now it's your turn. I want you to try these 2 problems, just 2. Make sure you pause the video so that you are able to write it down. And you're going to write down initially for each problem the given rate or ratio. And you can write it in either fraction form or with a colon. And then find the unit rate for each problem. Please make sure you show your work, pictures or showing the math that you're doing. Number 1 says, if Bob travels 50 miles in 2 hours, how many miles does he travel per hour? Remember that per means for 1 hour. The second one says, the veterinary hospital gives each of the adult cats in their care the same amount of food. If 3 cans are used to feed 2 cats, how many cans were used per cat for 1 cat? So set up your initial ratio, your rate in this case, of what is given to you. In this case, 3 cans are used to feed 2 cats, so there's your initial ratio. And then use that to find out how many cans per cat. So go ahead and pause the video and work on these problems, both problems, and when you're finished, press play to get the quiz questions to pop up. So pause the video. So to recap, today in this lesson you learned the definition of a rate and a unit rate, and you learned how to find the unit rate from a given practical situation. So great job! Make sure you have your notes in your binder, bring your binder to class, and I'll see you next time. Bye-bye!